All right, I just want to summarize the different transformations that we've just discussed. Basically, when we put these three different transformations all together, k being the vertical shift, k being the number being added or subtracted to the square. When k is positive, you get a shift up. When k is negative, you get a shift down. You also have the horizontal shift h. When h was positive, you get a shift right. H is negative, you get a shift left. But remember, this is the tricky part, that h is the opposite sign of what's in the parentheses. In the parentheses, you have negative h, which changes its sign. Okay? So if h is positive, then in the equation you would have x minus h. Okay, so that's where the sign changes. But again, h positive shift right, h negative shift left. And then a is where the shape changes of the parabola. When a is greater than 1, you get this stretch, so it gets narrower. When a is between 0 and 1, you get a compression, which makes it wider. And then when a is less than 0, it reflects downward, okay, and opens down. So basically, if I combine all of these together, I get a new formula for a quadratic equation, or quadratic function. It's called the vertex formula. Okay? It's a times the quantity x minus h squared plus k. Now the reason it's called the vertex formula is because if you think about where the vertex goes, originally with the x squared function, the vertex is at the origin. But when you shift vertically k units and horizontally h units, the vertex simply becomes h comma k. So as a general rule, the vertex is the ordered pairs h comma k. Whatever those two numbers are going to go into the parentheses here for the vertex, a point. Okay. Now, in addition to that, if we wanted to find other aspects of the graph, one of them that's very important is the axis of symmetry. The axis of symmetry, what we saw in the past, most of the examples we've seen in the past, the axis of symmetry was the y-axis. But when we shifted left to right, that axis of symmetry moved. The example I had in a previous video was right here, where we did the x minus 3. It was a shift right 3. Okay, and what happens is the axis of symmetry goes from x equals 0 to x equals 3. Okay, it's 3 units over, and in fact it will always match up with the h value from the vertex. Alright, so the axis of symmetry is always going to match up with the x value of the vertex, which is h, and it's always going to be an equation, because all vertical lines have an equation. We're going to, with a vertical line, it's x equals a number, and in this case it's going to be the h value. Okay. Couple other things to keep in mind. If you need to find a y-intercept, you simply plug in a 0 for x and calculate it. If you need to find an x-intercept, you simply plug in 0 in place of the function value, right? That's the y value becomes 0. And then you solve this resulting equation, right? And then finally, oh, maybe it's not finally. Let me think here. What else do I need? I guess that's about it. So those are the main things. Oh, the domain and range. I should mention those. Domain. The domain for these is always all real numbers. I talked about that in a previous video. And the range The range is actually going to start, so I guess it depends on whether this opens up or down. So if it opens up, the range will start at the minimum, the bottom value, and go up. The bottom value being the k value. I think I mentioned this in a previous video also. The range goes from k to infinity. If the graph opens down, meaning the a value is negative, then the graph comes up from negative infinity up to the maximum, which again is at the vertex, which is k. So negative infinity up to k would be the range. So it just depends on which direction, oops, missed my arrow there. Depends on which direction the graph is opening. All right, and now let's look at an example where we put all this together.